awesome about how math makes everything possible, but what do you think it means?
Anything you can do, see or move involves math.
One way is when driving a car. Years ago, cars travelled at 60 kilometres per hour. It has changed to 50 kilometres per hour around town and 40 kilometres per hour around schools.
Why was that?
We need to convert kilometres per hour to metres per second. We do this by multiplying the speed by 1,000 and then dividing the result by 60 to get metres per minute, and then dividing the result again by 60 to get metres per second.
So 60 kilometres converts to approximately 16.7 metres per second.
That's correct. If a driver takes 2 seconds to react before applying the brakes, we can calculate the distance the car will travel before the brakes are applied. Distance travelled will be calculated by multiplying 16.7 by 2. This gives a distance of 33.4 metres before the brakes are applied. Then the car actually has to pull up. Now the speed is 40 kilometres per hour in school zones. The reason is to ensure the safety of children.
Now we must repeat the process to convert 40 kilometres per hour.
40 kilometers per hour converts to 11.1 meters per second, which means it will travel 11.1 meters every second.
At this speed, the reaction distance is reduced to 22.2 metres. See, mathematics made it safer for the children.
Another area that uses maths is the coal mines. For example, a shot fire uses radius, time, and weight of explosive calculations on a daily basis.
Once the shots are in place, the shot firers are responsible for the safety of all equipment and workers. They must calculate a 250 metre radius exclusion zone for the equipment. Then the trucks move away out of the exclusion zone. And a 500 metre exclusion zone for all workers. And then the workers walk away and leave it to the shot firer.
Now let's see how the shot timer actually works.
Detonation starts at the dot at 0 milliseconds. The next shot is timed to go off 17 milliseconds after the first one. The third shot goes off 20 milliseconds later after the second shot, making it 37 milliseconds, and so on. The final shot that detonates in 292 milliseconds.
This is an example of a detonation. So how do we know how much explosive we need?
Amount of explosives per hole is given to us by the area of the hole, pi radius squared, times density of product, times depth of explosion. Using our example, the hole depth is 20 metres. The stemming is 5 metres deep. Diameter of the hole is 0.3 metres. The density of the product that we are using is 800 kilograms per meters cubed. Using our values from our example, we substitute them into the equation, making pi times 0.3 over 2 squared times 800 times 20 take away 5. This gives us a total of 848.2 kilograms of explosives per hole.
I understand now why maths makes everything possible.